Now let's derive the third equation of motion in this video using the same graph like the previous video. We know that S, the distance covered by the vehicle in time t, equals the area of this trapezium OABC. This time, let's use the formula for the area of a trapezium. The area of a trapezium is 1/2 the sum of the length of the parallel sides times the distance between them. OA and BC are the parallel sides and OC is the distance between those parallel sides. Hence, the area would be OA plus BC over 2 times OC. So replacing OA with U, BC with V and OC with T, we get S equals U plus V over 2 times T. We have derived an equation earlier which says V equals U plus AT. We can rearrange it to get T equals V minus U over A. Now we move back to this equation and replace T with this. What we have now is S equals V plus U times V minus U over 2 times A. Multiplying both sides by 2A gives us 2A times S equals V plus U times V minus U. Do you remember the identity A plus B times A minus B? What does that equal to? You're right. A plus B times A minus B equals A squared minus B squared. So we can write this equation as 2A times S equals V squared minus U squared. That's the third equation of motion, and these are the first two. There you go. Now we know that when an object moves along a straight line with uniform acceleration, its velocity, acceleration, distance covered, and time taken are all related. These equations, which we have derived graphically, are commonly known as equations of motion. So when we are provided with incomplete data, it is very easy to find the missing pieces of information using these equations. All this may look a bit difficult initially, but if you view the tutorials on equation of motion a couple of times, there is no doubt you will master the concept.